I request all of you to do a fabulous job by staying along with me till the end of this video. Definitely there will be a privilege and advantage after listening to this. I assure you there are some great pieces of advices for you. Try, adapt and learn from this video so you could make a mix and match of these ideas so that your work will go simpler. And coming to today's topic, that is on bilinear transmission, and this is from conformal mapping. So there are two problems flashing on the screen. The first one is find the bilinear transmission which transforms the point infinity I comma 0 in the z plane into 0 comma I comma infinity in the w plane. Whereas the second question, see here, find the bilinear transmissions which maps infinity I comma 0 into minus 1 minus I 1 in the W plane. So these two questions which you might see in the question paper very soon. So here solving these problems, so we have to learn the formula before. So here there are 3 points Z1, Z2, Z3. So these are the general points in the Z plane. So here these are the images of this general point, that is W1, W2 and W3. So in order to remember the formula, it is so simple. See here, keep one Z here. So keep one W here. And later keep one Z here and keep one W here. See how to remember this. So first of all, we have to take these 4 points. So that is bilinear transmission. This is Z minus Z1. And the next one Z2 minus Z3. Clear? Next one, so we have to ignore this one and we have to consider these 4 points. That is Z1 minus Z2. See here, this is Z1 minus Z2. And next one, this is Z3 minus Z. So which is equal to, first of all, we have to consider these 4 points. That is W minus W1. And next one, this is W2 minus W3. And next we have to consider these 4 points. That is W1 minus W2. And next one W3 minus W. So this is the formula which we are going to remember very easily. And next we are going to start the first problem, that is, so we have to find the bilinear transmission which transforms the point. So these are the points, that is infinity I comma 0 and 0 I infinity. So here first of all, so these are the Z points and these are the W points which you have to consider. See first, this is infinity I comma 0 and this is 0 comma I comma infinity. So if you make it as a Z1, this is Z2 and this is Z3. So this is W1, this is W2 and this is W3. So make sure that you consider Z front and here also one Z. So here one W and here one W. See here, this is Z and this is Z and this is W and this is W. See here, first of all, I'm writing the formula here. So here the formula is also very simple. So here this is Z, Z1, this is Z2, this is Z3. And next one you ignore this and you start these 4 points, that is Z1, this is Z2, this is Z3 and this is Z. So you make one subtraction. So this is how you have to remember the formula. And next one here also, first we have to consider these 4. That is W, W1, this is W2 and this is W3, and we have to take these 4 points, W1, this is W2, this is W3 and this is W. See here, this will be the formula. So which is very easy to remember. Clear? Now I am going to substitute each and every point here. So here Z minus infinity. See here, if I substitute, this will be Z minus infinity and next one I minus 0. Is it not easy? And next one we have to start from here. Infinity minus I. So this is infinity minus I and this is 0 minus Z. And next one here W minus 0. And the next one is I minus infinity. So if you substitute in the formula also, it is very easy. 0 minus I, this is 0 minus I and this is infinity minus W. So I am going to keep all the infinity values at one place. So here this is Z minus infinity and this is infinity minus I at one place, and this is I minus 0 is I and this value is 0 minus Z is, so this is minus Z. And the next one here is, so W minus 0 is W and this is minus I, and if you see, this is I minus infinity and this is infinity minus W. And now see, I'm going to solve this as, So limit n tends to infinity, so this will be, I'm considering this as a limit n tends to infinity. This is limit n tends to infinity. In place of infinity, I'm going to substitute n. So this is n minus I. So here also, so this will be I by minus z. So this is w by minus I. So this, in this term also, this is n tends to infinity. In place of infinity, I'm going to substitute n. So this is n minus w. So if I substitute infinity, this will be infinity by infinity. See here, this will be infinity by infinity. And clearly, and this is also infinity by infinity. So if I keep infinity here, so this is I by minus z, and here this is w by minus I. Clear? And now, so I'm going to apply L'Hospital's rule. So here, if I'm going to apply L'Hospital's rule as it is infinity by infinity, this is L'Hospital's rule. So here I have to make a derivative with respect to n here. So if I make a derivative with respect to n, z will be 0. See here, this will be 0, and n with respect to n, this is 1. So with respect to n, so this is 1 and this value is 0. Clear? And here also, if I apply L'Hospital's rule as it is infinity by infinity with respect to n, so this will be 0. So here there is n, this will be 1, and here n1, so this will be 0. Clear? And now as it is the same values, I'm going to repeat, that is I by minus z. So this is w by minus I, w by minus I. So this is also I here. So this value is, so this is minus 1. So this value is minus 1 by 1. This is I by minus z, and this is w by minus I. So this value is 0 minus 1. So this value is minus 1. So I can simply cancel this minus 1 as well as minus 1. And see here, if I send this to other side, so this will be minus I square by, this is minus z, is equal to w. So as you know that I square value here is, so I square value, everybody knows it is minus 1. So if I substitute I square as minus 1, so this will be minus of minus, this value is minus z, is equal to w. So here this w is equal to plus minus 1 by z. So clearly it is minus 1 by z. So this value is, if you consider this as z, so this is minus z. So if you cancel these two, so this will be w is equal to minus 1 by z. So this is how we have to solve. So this is so simple if you follow these tricks. The formula is also so simple. That is infinity minus I, 0 minus z. So first one, z minus infinity. So z minus infinity, I minus 0, divided by infinity minus I, 0 minus z. So here in the z plane also the same thing, w minus 0. So w minus 0, I minus infinity, divided by 0 minus I, and next one is infinity minus w. So here we have to apply infinity value. So infinity by infinity is 0. So infinity by infinity is undefined. So we have to apply L'Hospital's rule. After applying L'Hospital's rule with respect to n, this value is 1 and this value is 1. So these two are zeros. And see here we got minus 1 values, and therefore w value is equal to minus 1 by z. Clear? And the next question is also so simple, so easy as you got this one. So find the bilinear transformation. See here we have to find the bilinear transformation which maps infinity I0 to minus 1 minus I1. So in the W plane. So this is from Z plane and this is from W plane. So first thing here is, so this is infinity I comma 0, and this value is minus 1 minus I comma 1. So consider, see, consider these are all the z points. I'm considering this as z, and here also z. So this is w and this value w. So this will be, see here, this is z1, this is z2, and this is z3. So this is w1, this is w2, and w3. How to remember this? So the formula to remember here is also very easy. So first I have to consider these 4 points, that is z, z1, z2 and z3. And the next one I have to consider these 4 points, that is z1, z2 and next z3 and z. See here the formula is like this. So see here, so we have to subtract all this. And next one, here we have to consider all the 4 points, that is W, W1, W2, W3. And the next one, consider all these 4 points, W1, W2, W3 and W. See here, so you remember like this and it will be very easy. See here. So this is the formula which you have to substitute each and every value. So if I substitute, this will be Z minus infinity. So this will be Z minus infinity and I minus 0. Clear? And next one, here in the denominator, infinity minus I. And the next point is 0 minus Z. So this is 0 minus Z. So here in the same thing, that is W minus, what is W1? Minus 1. So it will become plus 1. So this is going to become a plus. And next one, this value is, so this is minus I, this is minus 1 by, so here in the denominator, so this is minus 1, this is minus 1 plus I, and next one, this is 1 minus W. 1 minus W. So here if you consider, so I'm taking this Z minus infinity. So this is Z minus infinity, this is infinity minus I at one side. This is I minus 0 is I, and this is 0 minus Z is minus Z. And here if you consider this one, this is W plus 1. So I want W to be positive, so I'm taking minus W minus 1, and here I'm taking minus common. So this is 1 plus I here, and if I take minus common, this is 1 minus I. So if I simply cancel all these values, so keep cancelling all these values. So here now I'm going to consider write this as limit n tends to infinity. See here, limit n tends to infinity. In place of infinity, I am substituting n here. So this is n minus I. So this will be I by Z. So this is I by Z, and this is W plus 1 by W minus 1. So here this is 1 plus I, and this value is 1 minus I. So if I rationalize, so here, so I'm multiplying with 1 plus I by 1 plus I, and see what happens here. So this will be, if I keep n infinity, so this will be infinity by infinity. So this is I by Z. So this is W plus 1 by W minus 1. So if I multiply, this is 1 plus I whole square. This is A plus B into A minus B. So this will be A square minus this is B square. Clear? So as this is infinity by infinity, so I am going to apply L'Hospital's rule. So if I apply L'Hospital's, if I apply L'Hospital's rule, see, I have to make a derivative with respect to n here. So this will be 0, with respect to n is 1, and this with respect to n is 1, and this will be 0. So into, this is I by Z, and this value, see, W plus 1 by, this is W minus 1. A plus B whole square is nothing but A square plus B square plus 2AB by, this is 1 minus I square is minus 1. Minus of minus, this value is plus 1. So here 0 minus 1 by 1 is, this is minus 1. This is I by Z. So this value is W plus 1 by, this is W minus 1. So as you know that I square value here is minus 1. So I square value here is minus 1. I am substituting minus 1 here. So this will be 1 minus 1 plus 2I by 2. So if I cancel these two, even 2 also if I cancel, so here I can cancel this plus I and minus I. So what remains here? So here definitely, so if I cancel, this will be minus 1 by Z is equal to, this is W plus 1 by W minus 1. I also got cancelled. So this is the thing which is left over, W plus 1 by W minus 1. And now I need the value of W. So in order to get the W alone, so I have to make a componendo and dividendo by applying, see here, by applying componendo and dividendo. So that is very simple. If you consider this fraction, so we have to add one time and we have to subtract one time. So if I consider this fraction as a by b, so minus 1 a will be like that, so I'm adding this z, and next one a will be like that, I'm subtracting for one time. So here also the same thing, fraction. So this is w plus 1, I'm adding this one, so add this one, and next one, so a will be like this, so we have to subtract, so this will be minus w, and this will be minus of minus plus 1. And see, this is plus 1 and minus 1, this is plus w and minus w. See here, this is minus 1 plus z, and this is minus 1 minus z, so this value is 2w. So here 2w by, so this is 1 plus 1, the value here is 2. So if I cancel this one, so we got z value alone. So w is equal to, so if I take minus common from this will be 1 minus z, and if I take minus common, this will be 1 plus z. So if I cancel these two, the w value is equal to, this is 1 minus z by, this is 1 plus z. So this is how we have to do. So these are all the proper steps from the textbook, so don't miss. So here infinity value is also, so don't feel hard, this is also very easy. So as this is infinity by infinity, apply L'Hospital's rules. That is, you have to go to the upper step and we have to make a derivative with respect to n. With respect to n, this will be 0 and this will be 1, this will be 1 and this will be 0. And see here properly we'll be getting minus 1 here. So here this step is also very easy, and this is also rationalizing. So and after applying component on dividendo, so we got w value alone. So here w is the plane, so this is of the form a, so this will be of the form that is az plus b by cz plus d. And this is how we have to solve, as these are very important questions. Definitely practice and learn more, and your practice should be consistent, not occasionally, and so that you will be benefited. Thank you so much for watching and staying till the end. If you really like, please share it with as many friends as you can. That is the greatest help needed from my side. And stay connected.